Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
This is it, the finale. 4 episodes deep into AWS reInvent 2025, and we're about to stick the landing.
4 episodes deep into AWS reInvent 2025, and we're about to stick the landing.
Over the past 3 weeks, we've covered agentic AI, infrastructure innovation, and Kubernetes at scale. Today, the data and AI services that tie it all together. Plus, the big question, what does all of this actually mean?
S3 tables with Apache Iceberg, Aurora DSQL going distributed, S3 vectors hitting general availability, and a comprehensive wrap-up that connects the dots across 50-plus announcements.
But first, because infrastructure never sleeps, let's hit the news. 4 quick items from this week that every platform engineer should know about.
Starting with security. Envoy v1.34.12 dropped on December 10th to patch CVE-2025-0913. This is a use-after-free vulnerability in the CAIR's DNS dependency that can crash Envoy if you've got malfunctioning or compromised DNS infrastructure.
Limited exploitability since an attacker would need control of your DNS, but still, patch immediately. Multiple versions got the fix. v1.35.8, v1.34.12, and v1.33.14. If you're running Envoy, especially in service mesh deployments, this is your wake-up call.
Next up, a milestone 3 years in the making. Rust in the Linux kernel is officially no longer experimental. The Maintainers Summit consensus? The experiment is done, and it was a success.
After 3 years since Linux 6.1, Rust is now declared a core part of the kernel. Not mature, not widely adopted, but officially endorsed as permanent infrastructure.
Linux 6.13 brought real progress. In-place modules, trace events, driver bindings for PCI and platform devices. Greg Krohartman said developers are almost at the write a real driver in Rust stage now.
And real drivers already exist. Android's Binder IPC driver is being ported to Rust, with experimental drivers covering network PHYs, block devices, DRM panic screens.
But here's the human challenge lurking underneath. Can Rust for Linux sustain a maintainer community when pioneers are leaving and some C veterans remain, let's say, less than welcoming?
The technical experiment succeeded. The social experiment? That's ongoing.
Third, Let's Encrypt just hit 10 years. December 9th, 2025 marked a decade of free TLS certificates for everyone.
The growth curve is staggering. In 2018, they were issuing 1 million certificates per day. Today, 10 million per day. They're on track to reach 1 billion active sites in 2026.
Impact check. When Let's Encrypt launched in 2015, only 39% of Firefox traffic was protected by HTTPS. Today, 80%. The tagline, encryption for everybody, actually delivered.
And finally, GitHub Actions had a brief incident on December 8th involving the Copilot GPT 4.0 model for completions, resolved within 30 minutes after mitigation. There was also a larger incident back on October 29th affecting Actions and code spaces, connection failures lasting about 7 hours.
Currently, everything's operating normally, but it's a good reminder that even the infrastructure providers have infrastructure problems.
4 news items showing what we always say: infrastructure never sleeps. Speaking of which, let's talk about what AWS wants to do with your data infrastructure.
S3 tables. Let's start there because this is AWS making a serious play for the lakehouse architecture market.
At reInvent 2025, AWS announced S3 tables has hit general availability with 2 major new capabilities: intelligent tiering for tables and automatic replication across regions and accounts. But first, the growth metrics. Since launch, S3 Tables has scaled to over 400,000 tables. They've shipped 15-plus features in the last 12 months.
And what is S3 Tables for those who haven't been tracking this? It's AWS's managed Apache Iceberg implementation built directly into S3. First cloud object store with built-in support for Iceberg table formats.
The original announcement promised up to 3 times faster query performance and 10 times higher transactions per second compared to running Iceberg yourself on vanilla S3. Automated table maintenance, optimized storage layout, all managed.
Now comes intelligent tiering. This is the same technology that saved S3 customers over $6 billion in storage costs, and they're bringing it to Iceberg tables.
3 access tiers: frequent access, infrequent access, and archive instant access. Data moves between tiers based on access patterns. AWS claims up to 80% storage cost savings without performance impact or operational overhead.
Here's why this matters. When you're running a lakehouse with petabytes of historical data, storage costs become existential. But traditional tiering solutions treat everything as blobs. They don't understand table structure, partitions, metadata.
S3 Tables intelligent tiering understands Iceberg semantics. It knows which files are hot query paths versus cold archive. It moves data based on actual table access patterns, not just object-level metrics.
That's the difference between storage tiering and lakehouse tiering. One saves you money on blobs, the other saves you money while preserving query performance guarantees.
The second big announcement: automatic replication for Apache Iceberg tables across AWS regions and accounts. And this isn't just S3 cross-region replication with Iceberg bolted on top. AWS built this from the ground up to understand how Iceberg works.
What does built from the ground up for Iceberg actually mean?
3 things. First, you can have your primary tables in standard storage class, but replicas use intelligent tiering for additional cost savings.
Second, separate and independent retention policies per replica. Your source tables might be retained for 7 days, compliance backups for 90 days, archival replicas for up to 7 years. Snapshot expiration works independently for each replica.
Third, it provides separate encryption keys per replica, improved security posture without managing key replication yourself.
So this is disaster recovery for data lakes that actually understands data semantics, not just copy these files over there, but replicate this complete table structure with all its snapshots and metadata, maintain consistency, and let me configure different policies per destination.
Exactly. And it reduces query latency for global analytics workloads. Distributed teams query local replicas for faster performance while maintaining consistency across regions and accounts.
Platform engineering angle, what's the integration story? S3 Tables integrates with Amazon Bedrock Knowledge Base for RAG applications at production scale. OpenSearch integration is now generally available, so you can use S3 Tables as your vector storage layer while using OpenSearch for search and analytics capabilities.
Wait. Vector storage in S3 Tables or S3 Vectors? Those are 2 different things.
2 different things. We'll get to S3 Vectors in a minute. But customers like BMW Group, Mixi, Precisely, Click, and Twilio are already using S3 Tables for data lake foundations.
The pattern I'm seeing, AWS is making S3 your lakehouse platform, not just your blob store. Tables become first-class citizens with table-aware tiering, replication, and maintenance. Let's talk Aurora DSQL.
Aurora DSQL, the distributed SQL database that got a standing ovation at reInvent. Announced as a preview at reInvent 2024, hit general availability in May 2025.
People actually cheered for a database?
They cheered for database savings plans even louder, but yeah, Aurora DSQL was the crowd favorite. And here's why. It's AWS's answer to, what if we built distributed SQL from scratch in 2024, knowing everything we know about cloud-native architecture?
PostgreSQL compatible, serverless, 99.999% multi-region availability. Those are the marketing bullets. What's the architecture story?
Aurora DSQL is disaggregated into multiple independent components: query processor, adjudicator, journal, and crossbar. These components have high cohesion, communicate through well-specified APIs, and scale independently based on your workloads.
Most databases are monoliths. You scale the whole thing. DSQL lets you scale query processing separately from storage, separately from coordination.
Correct. And here's the technical moment that makes this work. Amazon Time Sync service. They're using atomic clocks synchronized via GPS satellites, providing globally consistent time to every EC2 instance.
Wait, they're using GPS atomic clocks to solve distributed systems problems?
To solve the ordering problem specifically, in a multi-region distributed SQL system, you need to know the order of commits across regions. Traditional approaches use consensus protocols, which add latency. Aurora DSQL uses globally synchronized time to order transactions without heavy coordination overhead.
That's genuinely clever. Expensive to implement, but solves a fundamental distributed systems challenge.
And they're using optimistic concurrency control instead of traditional locking. Better throughput, higher system efficiency, no resource locking during transaction execution. Works well in a distributed architecture where lock coordination would kill performance.
Implementation detail that caught my eye, the project started 100% on the JVM and finished 100% Rust.
Complete rewrite mid-project. That tells you they were serious about performance and safety guarantees.
Performance claims, 4 times faster reads and writes compared to other popular distributed SQL databases. Compared to what? Under which workload?
AWS doesn't specify competitors in the benchmark, and popular distributed SQL databases is doing some heavy lifting there. CockroachDB, YugabyteDB, Spanner? We don't know. Early adopters, Autodesk, Electronic Arts, Klarna, QRT, Razorpay, they're exploring Aurora DSQL, not running it at production scale yet from what I can tell.
Use cases make sense, though. Multi-tenant SaaS applications, payment processing, gaming platforms, social media apps that need multi-region scalability and resilience. Industries like banking, e-commerce, travel, retail.
Here's my platform engineering question. When does distributed SQL actually beat well-architected sharding? Because I've seen teams adopt distributed databases to avoid thinking about data topology, and they end up with complexity in a different place.
Fair question. Aurora DSQL wins when you need strong consistency across regions, high availability with automatic failover, and you don't want to manage sharding logic in your application code. It loses when you have workloads that naturally partition geographically or by tenant, where eventual consistency is acceptable.
So, not a silver bullet, but for new global applications where you'd otherwise be implementing custom sharding and failover logic, that's the sweet spot. And the multi-region design is thoughtful. 2 regional endpoints, both supporting read and write operations, a third region acting as a log-only witness, single logical database, strong data consistency.
Operational trade-offs, you get 99.999% availability, no single point of failure, automated recovery. You give up control over data placement, query optimization, cost predictability under spike load.
Serverless always has that trade-off, simplicity versus control.
Let's shift to Zero ETL, because Zero ETL has been AWS's marketing slogan for 3 years now. What actually shipped?
At reInvent 2022, Adam Selipsky promised a zero ETL future. The first integration was Aurora to Redshift for near real-time analytics. 3 years later at reInvent 2025, AWS announced AWS Glue Zero ETL for self-managed database sources.
Self-managed meaning on-premises or EC2 databases.
Correct. Oracle, SQL Server, MySQL, Postgres, all replicating to Redshift through a simple no-code interface. Ongoing replication, not a one-time migration.
So Zero ETL is AWS speak for "will handle the plumbing."
Pretty much. You still need to think about schema mapping, data types, transformation logic, but the infrastructure for continuous replication, AWS manages that.
Platform engineering value proposition, reduce bespoke integration code. Stop maintaining custom ETL pipelines. Let AWS handle the operational burden of keeping data in sync.
And it pairs with database savings plans, which got announced at the same reInvent, up to 35% savings on database costs when you commit to a 1-year term.
Database savings plans got the loudest cheer at Matt Garman's keynote. Tell me why accountants and engineers both got excited about this.
Because it's flexible in all the ways reserved instances are rigid, auto applies across database engines, instance families, sizes, deployment options, and AWS regions. You can change from Aurora DB-R7G to DB-R8G instances, shift workloads from EU Ireland to US Ohio, modernize from RDS for Oracle to Aurora PostgreSQL, or from RDS to DynamoDB, and your savings commitment follows you.
Serverless deployments get up to 35% savings. Provisioned instances get up to 20%. DynamoDB and key spaces on-demand throughput get up to 18%. Provisioned capacity get up to 12%.
Supported services: Aurora, RDS, DynamoDB, Elasticache, DocumentDB, Neptune, Keyspaces, TimeStream, and AWS Database Migration Service.
1-year commitment, no upfront payment, flexibility to change technology underneath. This is the boring announcement that saves millions.
AWS CEO Matt Garman unveiled it with just 2 seconds remaining on his keynote lightning round shot clock. The crowd went wild.
Because platform engineers know cost optimization that doesn't require reserved instance Tetris is genuinely valuable. Okay, let's talk about the dark horse announcement, S3 Vectors.
S3 Vectors hit general availability at reInvent 2025. First cloud object storage with native support to store and query vector data. And the growth from preview to GA is staggering.
Numbers?
During preview, which only lasted about 4 months, users created over 250,000 vector indexes and ingested more than 40 billion vectors, performing over 1 billion queries. That's as of November 28th.
And the scale jump from preview to GA?
Preview supported up to 50 million vectors per index. GA supports up to 2 billion vectors per index. That's a 40x increase. And the bucket limit? Up to 20 trillion vectors.
20 trillion vectors in a single vector bucket. That's a lot of embeddings.
S3 Vectors improved performance too. Infrequent queries return results in under 1 second. Frequent queries now hit around 100 milliseconds or less. Write throughput, 1,000 vectors per second when streaming single vector updates into indexes. Retrieve up to 100 search results per query. Store up to 50 metadata keys alongside each vector for fine-grained filtering.
Cost story?
AWS claims up to 90% cost reduction when compared to specialized vector database solutions. That's Pinecone, Weaviate, and Quadrant in the crosshairs.
This is AWS doing to vector databases what RDS did to Oracle. Take a specialized workload, integrate it into commodity infrastructure, undercut on price, win on operational simplicity.
Regional expansion: 5 AWS regions during preview, 14 regions at GA. And the integrations are where this gets platform engineering interesting.
Bedrock knowledge base integration for RAG applications?
Yep, you can use S3 Vectors as your vector storage engine for production-grade RAG. And OpenSearch integration is now generally available, so you use S3 Vectors as your vector storage layer while using OpenSearch for search and analytics.
Customers? BMW Group, MIXI, Precisely, Click, Twilio, using S3 Vectors to accelerate AI search and power recommendation systems at scale without the complexity or cost of managing dedicated vector infrastructure.
When vector search becomes infrastructure instead of a specialized database product.
Platform engineering shift. 3 years ago, you'd evaluate Pinecone versus Weaviate versus Quadrant, stand up infrastructure, manage indexing, tune performance. Now, you enable S3 Vectors, start writing vectors, query them, done.
Same pattern across all these announcements. Aurora DSQL, distributed SQL without managing sharding. S3 Tables, Lakehouse without managing compaction. S3 Vectors, semantic search without managing vector databases. AWS learned from the EC2 RDS S3 playbook. The way you win is by making infrastructure disappear.
Let's talk privacy-enhanced AI. Clean Rooms ML.
AWS Cleanrooms launched privacy-enhancing synthetic dataset generation for ML model training at reInvent 2025. This is for organizations that want to train ML models on collaborative data without exposing raw data.
How do you train on data you can't legally see?
You generate a synthetic version of the dataset that preserves statistical patterns while de-identifying subjects. AWS uses a model capacity reduction technique to prevent the model from memorizing information about individuals in the training data.
So not just perturbing or copying the original data.
Correct. It's generating new datasets that maintain statistical properties of the original while quantifiably reducing the risk of re-identification. Organizations have control over privacy parameters, amount of noise applied, level of protection against membership inference attacks, where an adversary tries to determine if a specific individual's data was in the training set.
After generation, you get metrics to understand data quality across 2 dimensions: fidelity to the original data and privacy guarantees.
Use cases: campaign optimization, fraud detection, medical research. Any ML training scenario previously restricted by privacy concerns.
Example, an airline with a proprietary algorithm wants to collaborate with a hotel brand to offer joint promotions to high-value customers. Neither wants to share sensitive consumer data.
Using Cleanrooms ML, they generate a synthetic version of their collective dataset, train the model without exposing raw data. Both parties benefit from the insights. Neither party exposes customer information.
IDC predicts that by 2028, 60% of enterprises will collaborate on data through private exchanges or data cleanrooms.
AWS is adding a second layer of privacy protection. Synthetic data was already a technique organizations used. AWS is adding privacy-enhancing generation with quantifiable guarantees.
For platform engineers building data partnerships, this unlocks use cases that compliance would have vetoed. All right, we've covered the data and AI services: S3 tables, Aurora DSQL, Zero ETL, S3 vectors, Cleanrooms ML, database savings plans. Time for the big wrap-up. 4 episodes, what's the pattern?
Let's connect the dots across 50-plus announcements. Part 1, agents that work for days autonomously. DevOps Agent, Security Agent, Kiro, Bedrock Agent Core, Nova Act, and Werner Vogel's introducing verification debt.
Jordan. Part 2, chips and runtimes that make AI economically viable. Graviton 5, Trainium 3, Lambda Durable Functions, the Renaissance Developer Framework.
Alex. Part 3, Kubernetes infrastructure that scales to 100,000 nodes, EKS Ultrascale, EKS capabilities, MCP server for EKS, CloudWatch AI observability.
Jordan. Part 4, today, the data layer that makes AI training and inference boring. S3 tables, Aurora DSQL, S3 vectors, Cleanrooms ML.
AWS isn't selling AI features, they're selling AI infrastructure as a solved problem.
And there's a hidden thread running through every single announcement. Every single one is about reducing operational complexity.
S3 tables, automatic table maintenance, managed Iceberg compaction. Aurora DSQL, no sharding logic, automatic failover. S3 vectors, no vector database to operate. Cleanrooms ML, privacy controls without custom cryptography. Database savings plans, cost optimization without reserved instance Tetris. AWS learned from the EC2 RDS S3 playbook. The way you win is by making infrastructure disappear.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.